pick back up where I left off, I had this right here. The derivative of the inverse function is equal to 1 divided by the derivative of the function with the inverse function inside. So I'm going to go ahead and set this up right here. We have the derivative of f, the inverse of f of x. Oops. The inverse of f of x is equal to 1 divide, and actually let me go ahead and write what I was actually given. So the derivative of the inverse of tangent of x is equal to 1 divided by secant squared. However, instead of secant squared of x, it's 1 divided by the secant squared of the inverse tangent of x. So it's basically going to look like that. Now, once you get to this point, you're going to have to use trig identities to decide, or to get secant of x out. Basically, you're trying to get everything to be a tangent. You don't want a secant. So I'm going to go ahead and substitute that. So we have the identity that the secant of x squared, or the secant squared of x, plus the tangent squared of x is equal to 1. I do a little bit of algebra, and we basically get the secant squared of x is equal to 1 minus the tangent squared of x. Now, once we have this, we're at the right place because we know that the secant can be substituted for the secant right here. So I'm going to go ahead and do so. Or secant can be substituted for 1 minus the tangent of x squared. So we're going to have the derivative of the tangent, or the inverse tangent of x, is going to be equal to 1 divided by 1 over, or it's going to be divided, 1 divided by 1 minus the tangent of x squared, except instead of having x, you're going to have the negative tangent inside, or the inverse tangent, I'm sorry. Now, once you have this, you can notice that the tangent and the inverse tangent are going to cancel out, basically. So you do a little bit of arithmetic and you get those are both eliminated, and you now have that this is all equal to 1 divided by 1 minus x squared itself. Now you'll notice that this is identical to the formula that I wrote earlier, and that's actually what I want to happen. So once we have that, we know that we have found the derivative of the inverse of tangent by another means, and that was just basically by using the inverse derivative formula and then substituting, using trigonometric identities and substituting secant in for the secant in the formula. So now that we've done that, I'm going to go ahead and do the final problem. And you're going to see the chain rule, which I taught a little bit earlier, is applicable to this problem because you're going to go through the same process in order to solve this problem. So you gave us, or you asked us to find the derivative of, let me go ahead and make sure I got this correct. The derivative of the inverse tangent of e to the tangent of x. Now, if you look at this problem, you'll see that your first step is going to be to use the chain rule because you basically have a function inside of a function, you have tangent of x inside of e, inside of the inverse tangent of x. So, first step is we're going to go ahead and derive the outside, the very outside, which is tangent negative 1 of x. So we go ahead and derive that, and we're going to get 1 over 1 minus the inside squared. So it's going to be 1 minus e of tangent of x, and all of that's going to be squared. That's the derivative of the outside. Now you remember in the chain rule, you're going to divide, you're going to multiply the derivative of the outside by the derivative of the inside. So that's going to be multiplied by the derivative of this right here. Now we don't exactly know what the derivative of that right there is yet, so I'm going to go ahead and derive that off to the side. So the derivative of e to the tangent of x, and that's also another chain rule because that's a function inside of a function, a composite function. So we're going to get the derivative of e to the tangent of x. The outside is going to be just equal to itself because the derivative of e of x is equal to e of x. So we get that. We multiply that by the derivative of tangent of x, and that's secant of x squared. So it's going to be e to the tangent of x times the secant of x squared. Now that we have that, we can go ahead and substitute that down here. So we have the derivative of the outer times the derivative of the inner, which is what I just got right there. E to the tangent of x times the secant of x squared. And all of this is going to be times the derivative of the very inside, or the innermost function. the derivative of the innermost function is just going to be the secant of x squared. We take this right here. So basically, this is the derivative of the tangent, the inverse tangent of x times the e to the inverse, e to the regular tangent of x is right here. Now I'm going to clean this up just a little bit, and I'm going to simplify. So I'm going to go ahead and write this down. The derivative is equal to the secant, we have 2 secant of x squared right there. It's equal to 2 secant of x squared times e to the tangent of x, all divided by 1 minus e to the tangent of x. Now, upon looking at this is going to be your final answer, basically. We solved that by using the chain rule twice. If you look at this, you can also know that the secant of x squared can become the cosine of x squared if you go ahead and put that on the bottom. But that's just more simplification, and we don't necessarily need that. Again, thank you for watching. I'm Corey Beasley, and